Hi everyone, my name is Fabio, I'm part of the 0x team, and today I'm going to be presenting on 0x Mesh, a peer-to-peer network for sharing DEX orders. And it's one of the major initiatives that we have going on at 0x right now for two reasons. One is to offer a more decentralized trading experience on top of 0x, and the second one is to unlock the promise of what we're calling shared liquidity. So letting orders kind of move between different trading venues seamlessly. So just an overview of the presentation. I'm just going to give a bit of background on 0x. Then I'm going to talk about 0x Mesh, how it works, what it's good for, talk about some use cases from different entities in the ecosystem, dive into the tech stack, talk about this feature that we're really excited about, which is browser support, the ability to actually run this node in a browser. And then we're going to get into the workshop part, and we'll actually spin up a mesh node, connect to it via its JSON RPC interface, and play around with it. And in the end, we'll have, I think, a lot of time for Q&A. So a little bit of background on 0x. 0x is a decentralized exchange protocol built on Ethereum. The original version was launched in 2017. What we mean when we say protocol is that there's a standard order message format, and any exchange that has orders, okay, thank you. Any exchange that hosts an order book of orders that conform to this order format is essentially adhering to the protocol. And when they do that, they can use a single shared set of audited smart contracts to perform settlement. And they also get a bunch of developer tools that can accelerate their developer timeline. So things like a DEX UI kit, libraries for interacting with our smart contracts, and services for validating orders and knowing when to prune them from their order book. So since launch, we've had many projects build on top of 0x, and we've facilitated quite a bit of volume, but still early days. So 0x is different from other decentralized exchanges that you've probably heard of. We're not an automated market maker like Uniswap, and we're also not a fully on-chain DEX like Oasis. Instead, we do something called off-chain relay on-chain settlement. And what that means is that orders get created, signed off-chain, and they also get shared between counterparties off-chain. And then they only get submitted on-chain when settlement occurs. So they get settled on-chain, but the orders live off-chain when they get created. And what's really nice about this is it's much cheaper to create an order because you don't have to pay gas and submit a transaction on-chain. And so this actually adds a lot more activity on the trading side when compared to an on-chain order book. Another thing that this allows is for all these orders that exist off-chain to be put into an order book, so you can have bids and asks, and this is obviously different from like an automated market maker where you have a predefined price change depending on how much someone's buying or selling of the token. And our bet at 0x is that this order book style market will offer lower spreads and better prices than automated market makers, especially for large buys, because there isn't this like built-in price increase the more you buy, or slippage, I guess. And so yeah, we're very you can build a lot of things on 0x, but we're pretty bullish on this order book style market. Cool. So you have these orders. They live off chain. Where do they live? They have to be hosted somewhere, and they need to be found by counterparties. So right now, today, they're hosted on relayers. And a relayer is literally any entity that just hosts an order book of 0x orders and helps counterparties find each other. So we have all these relayers. All their orders conform to the 0x order format. So conceivably, an order from one relayer could be surfaced on another relayer. And this is particularly true of open order book relayers. But how do these relayers share liquidity? Well, like one naive approach is every relayer integrates with the APIs of every other relayer and pulls the orders in. But this is super inefficient because every single one of these connections is a custom integration. And as soon as a new relayer pops up, he can connect to all the other ones, but if he wants them to pull from him, they need to do engineering work to make that happen. So it's very costly, it's very cumbersome. And so what we've seen is there hasn't been as much sharing of liquidity. And this is actually one of the reasons for why we built Mesh, is we wanted to solve this problem in such a way that anyone can share liquidity with anyone without knowing who they are ahead of time. And so we built Mesh. So Mesh is a gossip-style peer-to-peer network for sharing 0x orders. You can kind of think of it like BitTorrent, but instead of sharing music and movies, you're sharing cryptographic commitments to buy or sell a given asset. There are obviously other differences with BitTorrent. You know, the content is not static. Orders become invalid. So, you know, if an order gets filled, canceled, or expires, you have to remove it from the order book and no longer propagate it. And so, yeah, that's why we use more of this gossip style network, but the analogy still holds. So anyone can spin up a mesh node. They'll immediately get connected to a neighborhood of peers. And then what they can do is they can open up an order stream, or what is a subscription, to their node. And they're going to get these events coming in. Hey, I just discovered this new order. This new order exists. But not only will it tell you when it finds new orders, it'll also tell you when an order expires, gets filled, etc. So it's giving you all the updates about the orders that it knows about. The mesh nodes use Ethereum for two reasons. The first one is to validate the 0x orders. The second one is actually to prevent some resource exhaustion attacks. So what we do is we take the digital scarcity of some asset on the Ethereum blockchain and we link that to the resource scarcity of the entire network. And in so doing, what we can do is actually piggyback off of some of the denial of service protections that blockchains have, even though we're an independent peer-to-peer network. So that's really cool. So what are some of the benefits of Mesh? The first is it offers a completely decentralized off-chain order propagation mechanism. You know, if you don't want to build a relayer or you don't want to use a relayer, you now have an alternative. And for some projects that we've spoken to, this is actually very important. They don't want to introduce like any sort of centralized single point of failure. Another thing that it gives us is this concept of shared liquidity. So you can seamlessly add your order to the network, and then anyone else who's plugged into it can pick that order up. And if the people plugging in have interfaces, you know, or trading venues, and have access to retail traders or even sophisticated traders, they can now have access to those orders. And the last one is market formation. So let's say you're bootstrapping a new market. You have this new asset that you want to create. Right now, the playbook is get listed on a centralized exchange, pay them a bunch of money, and then your users can start trading your token. But instead, why not let your users trade with each other over a neutral, permissionless network where you can list yourself. So. Okay, so now I'm going to go through like a couple of use cases for Mesh for different players. So let's say you want to build a DEX. One of the really cool things that you can do is you can solve this chicken and the egg problem of bootstrapping a two-sided market by plugging your exchange into Mesh and mirroring the liquidity that you find on Mesh on your exchange. So when your first user comes to your site, they don't see this. Instead, they see this. So it looks like there's already a lot of liquidity for them to take, and there actually is. And so it's going to increase the likelihood that they're going to stick around. Did you have a question? Or? No. Okay. Another use case is, let's say you're creating a new asset, and instead of going to Binance and paying them a bunch of money, what you can do is you can take this open source DEX UI kit that we've put together, together with Mesh, and you can launch your own DEX. So your own exchange where users can visit the site and can start buying your new token. And this is actually a live example of a project called Verisafe, and they did exactly that. And let's say you're a market maker. So Mesh can also be kind of seen as a way to have your orders show up on a whole bunch of relayers. Instead of building custom integrations with each relayer, just build an integration with Mesh, and anyone who's plugged into it will have those orders surface. And I think what's exciting here is that, you know, there's a whole bunch of relayers you might know about, but there might be new relayers popping up, you know, new wallets, new players that, you know, have access to users who want to trade, and your orders just seamlessly get found by everyone. Another interesting side effect of Mesh is, you know, market makers are used to interacting with traders, you know, via some sort of exchange intermediary. And the exchange intermediary kind of defines the rules of like the game. So they essentially design the market mechanics on how market makers interface with traders. And that kind of constrains the types of strategies types of strategies that market makers can use to kind of like a more limited set than the full gamut. And with Mesh, there's actually the potential for market makers to be connected directly to traders. And when that happens, all of a sudden market makers can start to innovate on the exact market mechanics that they use to offer better prices. And so some examples that we're seeing people play around with is you know, creating a request for quote system where market makers can put into the Mesh network orders with you know, the price that the market maker is willing to give, you know, any counterparty. So it's typically a worse price. And then a trader can find that price, can identify that that order, you know, follows a certain set of rules, and then respond to the market maker saying, hey, this is who I am, what price will you give me? And then the market maker can offer them a better price. Another example is like price matching Binance. So what the market maker can do here is, again, kind of create a bunch of orders at very terrible prices, but promise that if you ask them to fill that order on your behalf, that they'll give you a refund of the difference between that bad price and the price of Binance at the point where they submit the transaction to the blockchain. So I'm super excited about this. I think there's a lot of potential here for innovation and for competition. And I think it's going to bring down spreads, and it's going to make the market more efficient. So let's say you want to trade the newest, coolest experimental asset that just got created. Let's say it's Stablecat. It's a stable coin backed by CryptoKitties. Super cool. But you know, Stablecat, they've got like 111 backers, like people who are passionate about what they're doing. It's not really like big enough yet for even a relayer to list this token. So what they can do instead is, and let's say Stablecat also doesn't want to build a relay, right? They don't want to like be running a trading venue. I'm going to be talking more about browser support later, but what it's going to enable is for someone to run an in-browser mesh node. And so what they could do is create, just send out a link to an IPFS, IPFS hash. When a user clicks on this, it will open up an open source DEX front end, and it will also spin up an in-browser mesh node, and it'll automatically connect everyone who's clicking this link to everyone else who's clicking that link. And so all of these 111 backers can all of a sudden start trading Stablecats without it being listed anywhere, and without having to go through that hurdle. So I think that's really exciting, because it means, you know, eventually it'll be as easy as, you know, just customizing maybe some parameters in a URL, and you have a fully decentralized DEX. Yep, cool. So what is Mesh built with? It's written in Go. We're using libp2p for a lot of the networking layer. So we use Gossip Sub, Kademlia DHT, AutoNat, PeerStore. And for those of you who don't know, libp2p is a networking stack. So it's a bunch of interfaces and libraries that you can use to build peer-to-peer networks. We're using LevelDB for our persistence layer and Aetherium for interfacing with Aetherium. So I guess more about like how we pulled off browser support. The first thing that we do is we take our Go code and we compile it to WASM. For the database, we found a way to use LevelDB in both the browser and the server. In the browser, what we do is we just shim all the file system calls using browserfs. And then, yeah, libp2p, you know, it compiles to WASM, so that's great. We had to configure the PeerStore to use LevelDB. That was pretty easy. I think the heaviest lifting was actually here. So we support multiple transports. So we use TCP when we're connecting to non-browser peers, WebSockets for browser to non-browser connections, and then WebRTC for browser to browser. So WebRTC was actually developed by Google. It's web real-time communication. It's for their Google Hangouts product. But it also enables a data stream to be set up between two browser tabs. And it's actually the only transport layer that can connect two browser tabs without any server in between them. But because for their use case, they didn't really care about the decentralized aspect of it, bootstrapping that connection, so starting that connection, it still requires some sort of intermediary. So you need an intermediary that you can dial, because you actually can't dial a browser tab, right? And so we're working together with Protocol Labs to essentially enable any third peer in the network to act as a relay to set up that initial connection. But once it's set up, the connection is going to be directly between the two browser tabs. And we actually just added browser support in the latest beta release. This was last week. So it's super exciting. It's still early days. Performance, there's a lot to improve there, etc. But we've proved that it works and that that it runs in the browser.
I guess for a browser, you don't just go Ethereum, right?
Sorry, yeah.
I guess for the browser client, you don't just go Ethereum, you use directly bot free?
No, so we're still using Aetherium because it's also being compiled to WASM, right? So all the code that's in the, so yeah, let me talk a little bit more about that. If you're using Mesh in the browser, what you're going to do is just install an NPM package. But inside of that NPM package, what we actually have is the WASM bytecode. And then around that we have bindings, so JavaScript or TypeScript bindings. So from your perspective, it's like interacting with any other JavaScript library, but all the code is actually running in WASM. Cool. So now we're going to go through and actually like spin up a mesh node, play around with it. Let's hope the demo gods are with us. And I'm also hotspotting off my phone, so we'll see how that goes. But yeah, so essentially, if you do want to follow along, like I put these bit.ly links in here, so you can, get the snippet of code if you want. And the snippet actually even has an RPC endpoint, so you don't even have to bother with that. But here you can see, like, we're opening up a port for the JSON RPC interface. We're opening up a port for the P2P traffic. And then we're just saying we want to be on mainnet, and that's pretty much it. So let's see here. Cool. So I just copied that over, and I put in an Aetherium node. So let's spin that up and cross our fingers. So it's booting up. It's finding a bunch of peers on the network that are already there and who speak our protocol. And then it's going to... So some of the peers obviously won't be able to connect to them. Let's give it just a little bit more time to see if we can start receiving some orders. And maybe in the meantime, while this is happening, oh, okay, could not connect. Okay, so while this is happening, let's just get back here. So Oh, yeah. So I guess connecting to Mesh, the way that you would do that is you can either use our official TypeScript client or our Go client, or pretty much any other JSON RPC client that's out there if you want to use a different language. There's some niceties in ours, obviously, but yeah. Cool, so here we go. Starting to receive valid orders, so that's exciting. So our node is up and running. And okay, so let's see. So the first call that we're going to do is we're just going to get some statistics about our mesh node. So here you can see this is the TypeScript RPC client. We're instantiating a new one. And we're just calling this getStats async method, and then we're going to print it out. So here, if I do that. Okay, cool. So we got some data back. We have 12 peers. We're storing 264 orders as of right now. You know, this is the latest block, etc. And if we do another one, let's say we want to connect to the order stream and we want to see all the orders as they're coming in, as well as updates about those orders. We can call this subscribe to orders async method. And yeah, that just takes a callback and gives us all the order events. So let's do that. Okay, cool. So here you can see these orders are getting expired. That's probably the most, that and added are the most often events that get fired. And yeah, we get, you know, the entire order, the order hash, you know, what the event represents, as well as like how much of this order is still fillable. And maybe we can see if we can see some added coming in. Someone post an order. Added, there we go, cool. So we also got one that got added, and now it's already gone. Yeah, there's quite a few orders coming through. All right, sweet. Let's see. We can also get all the orders here. You know, we're not going to print them all out because there's quite a few. So we'll just print out the number that exist. Cool. So there's now 519 orders stored by this mesh node. Okay, cool. And so what about like more advanced queries? So mesh, you know, the database that we use for mesh is LevelDB. It's a very low level key value store database. So it doesn't have a very kind of expressive querying language. So I think there's going to be multiple ways that people do this, but one is, you know, sync the external database of your choice with a mesh node, and then you can just use whatever querying language comes with that database. So if you like SQL, just sync it with a Postgres database, and then you can query it using SQL. We have a handy little tutorial on how to do that. It's, you know, not that hard. Another thing that you could do though is we actually, thanks to Jacob, we actually have LaunchKit, which is kind of like a, you know, a demo relayer or a starting project relayer that integrates with Mesh. So that'll give you the standard relayer API. And this is kind of, you know, what the front end looks like. And this is for ERC20. And then we also have another UI for NFTs. And this, you know, kind of comes out of the box with support for Mesh. And then something that we're working on now is building a Mesh gateway. So this is just going to be a hosted set of APIs that provide access to the Mesh network. No need to run a node to access the network if you don't want to. You can use the gateway, and this is the same concept of like an IPFS gateway, which, you know, Cloudflare is hosting and a bunch of other people. Cool. So I also wanted to show you the browser interface. So it's very similar to, like, I guess, similar to the other one, but here you're actually, you know, importing the browser package, and then you're literally starting the mesh node, right? But yeah, you're going to have a bunch of handlers where you can handle the order events, etc. So to the end developer, it just looks like JavaScript, even though under the hood it's running WASM. Cool. So here are some links. This is our GitHub. Discord where you can always chat with us if you're interested, and then also our documentation pages, which are actually pretty kind of fleshed out. Like we have the whole JSON RPC API interface, like the browser API. If you want to participate in our beta program, how to do that, how to deploy, and then also kind of like all the methods that are available in our Go and TypeScript clients, and how to contribute if you want to contribute. So cool. Thank you so much. Any questions? Who has the mic? Oh, nice. Cool.
Can I ask?
Yeah, go for it.
So, I guess like before trading, we need to log the assets, right? Before the trading, we need to log the assets.
Before trading, you don't need to lock the assets, but you do have to set an allowance to the 0x protocol.
All right.
Yeah.
And do you support like ERC77 or only ERC20? 777?
No, we support 1155 though. So they're very similar, okay. But I guess we feel strongly that 1155 is going to be the winner. Like it's better. It's a better standard, but it wouldn't be that hard for us to add support.
Do you support more standards than?
Yeah, so ERC20, 721, 1155, and I think there's
1055, right?
Sorry?
1055?
1155.
Okay.
It's also the one where you essentially have multiple ledgers within a single smart contract, right? Mm-hmm. Are there any other ones that we support? No, I think that's it for now.
And other blockchains? Are you planning to support other blockchains?
So not in the short term. We're still kind of waiting to see kind of which ones actually make sense to build on. We'll go wherever kind of like the trading activity goes, or wherever the like valuable assets get created with like novel use cases.
Okay.
Yeah.
And last thing is that I mean, did you measure the throughput? What would be the maximum throughput here? I mean, that would be the transfer of the Ether, right? Of the Ethereum.
Throughput of settlement?
Yes.
Yes. Yes. So that's the case today. We have another team at 0x that's working on scaling that. And the way that we're going to be doing that is using zero knowledge proofs and a deposit contract. So you'll be able to deposit your funds on the Ethereum mainnet, and then do transfers off chain, but then have them be batch settled on chain.
What's the license?
For all of this, Apache 2.
Okay, so no one can copy it and do it their own way.
Absolutely.
Okay.
Yeah,
cool. Thanks.
Feel free to hack.
Are cancels still done through main chain, or can you do them through the mesh?
That's a good question. So mesh doesn't actually kind of try and solve the cancellation problem. So the default is that it still happens on chain. We are, experimenting with this coordinator model that we've built that enables off-chain cancels, so soft cancels, and we are going to make mesh play nice with coordinator. We think.
And does fill information come through the mesh, or do you have to?
Yeah, so I think that's another kind of like really big improvement for anyone building on 0x. You don't have to build your own order book pruning logic anymore. It will tell you of every fill, cancel, etc., and it'll even tell you like this is how much that's remaining to be filled of this order. So you can take that information, you can just update your database pretty easily. Mm-hmm. Cool, awesome, thank you so much.